I know a lot didn't just happen there, but believe me, a lot did just happen. So, as you can see, I have a pendulum set up that is a string attached to a nut attached to the ceiling. So, imagine every time I swing this that it's traveling in a straight line. Otherwise, this isn't going to work. You see, what happens is, right now, where the pendulum is the reference point. This is basically the origin. So if you had a graph, this would be 0, 0. So let's say when I pull back, it moved about 3 inches to the right. And you see, the way we would define this is we would say its position relative to the reference point would be 3 inches to the right. And that is how we define position, because it is distance and direction from the reference point. But let's say I move it from the reference point to 3 inches to now 2 inches to the right. So now what we would say is, well, it went 3 and it started here, and then it moved to the left 1 inch. So what we would say is the position is 2 inches from the reference point, but the displacement was only 1 inch because it only traveled 1 inch right here. So now, let's say I pull it back to 3 inches, and I let it go down and back, which would be 6 inches, and then 6 inches back. Well, now you would say it was displaced 0 inches, and the position didn't change, but it did do something. The distance changed, the total amount of distance. So since it went 6 inches down and 6 inches back, that's a total of 12 inches, or 1 foot. So now you would say, from this point, if we started at this position of 3 inches to the right, it traveled a total of 12 inches from here down to here, which is 6 inches, and down to here, which is back. But its displacement didn't change. So now let's say, well, I want to swing it and then stop it right at the reference point. Well, then what we would say is its position is at the reference point. It's 0, 0. But the displacement was only 3 inches. Only 3 inches. And it was 3 inches to the left. So it was displaced 3 inches to the left. But the distance it traveled was a total of 9 inches, because it went 6 inches down and then 3 inches back. So to recap, position is distance and direction from the reference point, and displacement is overall change in position, otherwise defined as a vector. The direction does matter for displacement. However, distance does not take into account the direction. It is always positive, and it is the length it traveled total. And we also call this a scalar, just like displacement is called a vector. So as you can see, this is the reference point for this pendulum. So what happens if I had changed the length in rope? Well, currently it takes about a second or two for this amount of rope. But let's say I were to change it and make it shorter. Well, that was a lot faster. So what happens if we specifically calculate the length of rope so that when we swing the pendulum, after a certain amount of time that we want, we can make this pendulum link back up with other pendulums linked behind it? Well, I already have a machine like that built, and that is called a wave pendulum. So let me show you my wave pendulum. See here, this is my wave pendulum. And what happens is, I have very specific lengths of rope, so that after about 20 seconds, these pendulums should link back up. And the way this works is, this is a longer pendulum, so it takes a longer amount of time for it to do a full cycle. And back here is the shortest pendulum, and it's very fast. But after a certain amount of swings, they all link back up because of the very specific calculation I had to make to get these lengths the same. So let me show you what I mean when they link back up, about after 20 seconds. Oh, here we go. Now, obviously, this wave pendulum isn't perfect, and if you could see, when I released them, some of them went a little early, and there's many different factors, but basically, after a certain amount of time, they'll all come to a complete stop. And you wouldn't say that it didn't travel any distance, because you would say each pendulum traveled a distance for the amount of times it totally swung. But its position is still at the reference point because that's where it ended. And then you would say its displacement is also zero because it did not change its position from when it was zero.